we've seen the scientific revolution and the development of ideas of gravity and the universal law of gravity. And this was like a huge thing back then, because this mechanistic idea was that the world is a sort of machine. So there, people like Newton developed the kind of the laws of motion and managed to see the world as a machine. So it led to this view of the world as being this vast, the whole universe is just a machine governed by physical laws and everything being ultimately predictable. So if there are physical laws and you've got all the starting conditions and you have good math, then the motion of everything in the universe would be entirely determined by these laws. And we were starting to get to the stage where it became clear that we could make very precise predictions. So this led to this kind of whole revolution and the rise of empirical observation and moving away from sort of mystical explanations to a much more scientific view. So, we've seen people like Galileo, Kepler. There was also the scientist Bacon, who had whole new scientific approaches. Now, this one of the central ideas of mechanism is, if you think of like two balls, two hard balls, maybe like two pool balls hitting each other, then that's governed by the laws of motion and they'll bounce off each other. So there's also this idea that the world is made of corpuscles. This is an idea shared by Descartes and Locke and other kind of scientists of the time, that basically everything is made of little atoms. And these atoms are solid atoms of, they're very small, and they kind of, the motion of everything can be explained by these hitting each other. So Descartes was one of the people to kind of develop this kind of idea, this idea the universe operates like a machine. And then there's a big question about, well, how does gravitation work? If everything has to go, if two things to interact, they have to hit each other, then how does the sun have a hold on planets going around it? Because it doesn't seem like there's anything going between them. So Descartes suggested that the whole of space has particles in it, and these particles are moving round in vortices, and it's by this invisible motion of things moving around that they guide the planets around the sun. Which is a total speculation, but he's sort of driven to that by his belief in mechanism. He says, well, it has to be some way. So there's this belief in vortices without any observation of vortices. We're going to be talking about his mind-body dualism later on, but he thought the physical world is just completely mechanistic. All right, so that was one approach, but another approach is that gravity is actually a continual miracle performed by God. And that's a sort of surprising idea. So the question is, how can it possibly be that planets are going around the sun, like the sun is exerting a force on those planets, if they're not touching? So we've seen Descartes' possible explanation, which seems pretty far-fetched and pretty speculative. But then what else could it be? So Isaac Newton had his laws of gravitation. So he was arguing, he's saying, look, these planets the motion of these planets can be explained very well by the law of gravitation. So there's a lot of confirmation for it, but it doesn't explain how gravitation works. So it kind of led to this puzzle. Well, how does it happen? And people just didn't really know what to say. So Newton's laws gave you a description of what was happening without a real explanation for how it was happening. Now, he didn't think that there could be vortices. He didn't believe in like the sort of this physical ether. So Newton had this theory that God is kind of like pushing the planets around all the time. Just seems like that doesn't seem very scientific, right? It seems like you're bringing God in, doing everything all the time. But he thought it was like a continual miracle, that God is always moving the planets around, and that's how gravity works. It's an odd sort of theory. It doesn't seem very scientific. It seems to be combining this theology with science. And we just talked about how this new science was all empirical and based on observation. And you have Isaac Newton saying, oh, God's doing all of this stuff. That doesn't seem very scientific. But in some ways, the idea was, well, that's the only possible way you could explain it. He had a defender. There was a guy called Samuel Clerk who defended Newton's views. And he got into dialogues with Leibniz, the German philosopher. So Clarke argued that God can move matter without any physical contact going on. So there's always this immaterial God cause, which is, so you have action at a distance, two things influencing each other because of God. So he's totally bringing in this theological approach to Newton's theory of gravity. That was like the only way they could possibly explain it. Leibniz didn't think that made any sense whatsoever. He thought that was just like, he thought it was totally weird. And so Leibniz says, you have to be scientific about this. So Leibniz said, well, we live in a rational universe. There are rational natural laws, and everything is all motion has been arranged from the beginning of time. It's a little bit like the idea that the Stoics view that the world is totally rational. It doesn't necessarily seem a great scientific theory, the idea that everything has been arranged from the beginning of time. It seems a little bit kind of odd. But all of these scientists are trying to grapple with how can there be gravity when we don't see any contact between the sun and the planets. And so they're all coming up with these possible theories, none of which make a lot of sense. So the whole idea of action that is distance seemed to challenge the assumption that the world is just like a machine and that everything interacts by touching something else. So it led to big debates about the nature of causality and how do we understand one thing causing another. And we're going to see the skeptical view of David Hume, but also some other more sort of scientific views. So it really led to it was a sort of continual crisis. It was an embarrassment for science to be saying everything's mechanical, everything's scientific, and yet we can't explain how the sun is able to hold on to the planets and make them go around. So it kind of led to some suspicion that there were limits to mechanical philosophy. But it wasn't until at least kind of 200 years later that scientists started to develop field theory. There were scientists like Faraday and Maxwell, especially thinking about electric fields, electromagnetic fields, they developed field theories. And then field theory got developed for gravity. So they started to have totally new ways to think about kind of science and how things interacted. So the idea of a force field with you have different forces like magnetism and electricity and gravity. And then that got developed in the 20th century to include subatomic particles like quarks, and you started to have new forces like color. That was like a total kind of total change in science. So it was always a problem for the mechanistic view, and field theory helped to solve those problems. There are still questions about how to understand field theory, and that leads to a lot of debate in philosophy of physics about how to understand all of this stuff. So that leads us to our final slide. So just to kind of emphasize these different parts, that there was this mechanistic view, which everybody agreed on in the 17th century, but there was the embarrassing phenomenon of gravity, which didn't seem to fit in with the mechanistic view, and eventually led to kind of more scientific thoughts about that. All right.